Hello, good afternoon, and welcome to our third Friday lunchtime webinar. I'm Chris Gaze, and I work with the Future Homes Hub. And I'm just going to do a few notices while we wait for people to turn up. So, as I said, this is our third in our series. In 2 weeks' time, we will be looking at heat pumps, a builder's perspective with the help of John Petts of Telford Homes, which are primarily, of course, apartments, and Trudy McCormick from Keepmoat, which is houses, and Charlotte Lee from the Heat Pump Association. Today's topic is looking at TM59. Using TM59 dynamic modelling in practice, it goes along with the paper or the guidance that we have on the Future Homes Hub website, and I'm really pleased to be joined by the authors today, which is Susie Diamond from Inkling and Richard Partington from Studio Partington. I asked them if they would introduce themselves. Richard said that Susie was the brains and that he provided the pictures, but I think it may be a slightly more sophisticated response to that from the joint authors. They're going to present for 20 minutes, and then what we'll do is we will have a Q&A session. You can put your questions in at any time during this webinar by clicking on the Q&A icon that you should probably be seeing, at least if you're using a PC or a laptop on the bottom of your screen. It should say Q&A with a couple of speech bubbles over the top of it. And I will then gather up those questions, and then we'll try and field and answer of them as many as we can. Can I ask also, though, if you could try and keep your questions to the TM59 topic? I know these guys are very interesting and could answer questions about all sorts of things, but today we will be limiting that to TM59. And also, one question which everybody always likes to ask is, will this be recorded? And the answer is yes, it is being recorded, and it will be then put up on the Future Homes Hub website sometime within the next week. So with no more delaying from me, it's great to welcome Susie and Richard, who will share their presentation and tell you what they've got to say about TM59.
Thanks very much, Chris. Share coming through. Is that coming up for everyone?
That's lovely. Thank you.
Fantastic. Hello, everyone. Thank you very much for inviting us to talk about this work that we've done with the Future Homes Hub, looking at the dynamic thermal modelling method within Part O. Let me wait my slides to move on. There we go. So I'm just going to give a bit of an introduction to this dynamic thermal modelling route and how that relates. Sorry, I'm trying to remove everyone's pictures so that you're not. Yeah, there we go. I can see my screen. So yeah, essentially within Part O, there are two main compliance routes. You're probably familiar with this. There's a simplified method and the dynamic thermal modelling route, and it is that dynamic thermal modelling route which follows TM59, SIBSE TM59 that we're going to talk about today. But just to highlight that regardless of which route you're following, there are additional requirements within the approved document O on noise at night, and that can affect whether bedroom windows are able to open or not. Security, and there are specific requirements to make sure that easily accessible bedrooms, for example, that those windows are not allowed to open under Part O at night, or they have to be able to open securely. Not entirely clear how that is defined. And there are additional requirements around protection from falling, so looking at sill heights and the maximum reach that windows can open outwards. So those apply regardless of which method you're following, and it's really important to just bear those in mind so that we don't forget. So the dynamic modelling method, as I said, follows SIBSE TM59, which is a methodology that was first published in 2017, and there is an update pending, but that should be out later this year. It's not going to radically change, but there are a few changes coming, so watch this space for other webinars that we're giving on that one as it gets finalised. But the method does rely on specialist software. So in order to do the dynamic modelling, you need dynamic modelling software. So that's TAS, IS, Design Builder, generally are the main commercial softwares in the UK. And you'll need someone who knows how to work those softwares effectively and correctly. The assessment will look at a whole summer, so from the 1st of May through to the 30th of September, and that uses real synthesized weather data, but a whole weather year of weather data. There are 2 criteria that you need to comply with. One, criterion 1 or A, looks at the hours of exceedance during the day, predominantly for occupied spaces, and that does extend for bedrooms, but it's effectively looking at how well spaces cope with overheating risk during the day. And then an additional criteria focused on bedrooms, which looks at comfort levels overnight specifically. So as opposed to some of the TM52, which was the commercial buildings overheating risk assessment, we are interested in bedrooms and sleep quality at night with TM59 and homes. And in order to pass, every room needs to meet both of those criteria where they're relevant. So pass, fail. You can pass criterion 1, but still fail if you're not also meeting criterion 2 in a bedroom. So where there is areas of non-compliance, your modeler should be able to give you some commentary on the key reasons why there is exceedance in those particular spaces, and that's usually down to sort of high exposed glazing areas or lack of shading or windows that don't open wide enough. And there are some sort of common features that trigger failures. Sometimes they're very narrow, sometimes they're much more extreme, and it's worth getting a picture of how far over the limits a space is failing, because obviously that has implications for what the mitigations might be. And the other thing to be aware of under Part O is that you can't include any internal blinds or curtains within the modelling assessment, and that used to be quite a common addition pre-Part O that was quite helpful at reducing solar gains. But for whatever reason, even bedrooms, we can't include blinds or curtains as part of the shading mechanisms. We can include them if they are fixed shutters, for example. So I think they can be movable, but they have to be installed shutters internally or externally, can be approved in the modelling. So some additional benefits of or features of the dynamic modelling route include a much more flexible weather data. So it's not infinitely flexible. We've got 14 Susie weather files available, weather locations available. There's a map. I don't know if it's big enough for you to see actually where they all are, but they're spread across the UK. And you should choose the weather data closest, most relevant to the site that you're assessing. And those are essentially, they're called future weather data. They are based on the 2020s, so less future than they were once. And Susie are currently working on new weather files, which we can talk a bit about, but actually they're not published yet and they won't be out until much later in the year, so we're not certain what they're going to look like. But it's the 2020s DSO1 50th percentile high emissions scenario, specifically files that TM59 requires you to use. Your modeler will know all about this, and they are purchasable from Susie, but it is important that you use those files specifically. And one of the key advantages that using the dynamic thermal modelling route gives you is that the ability to reflect the design more accurately, particularly including shading devices. So you might be designing in shading that doesn't quite meet the simplified method shading, which is quite prescriptive and quite onerous and needs to include every single solar exposed window. You might be designing something more bespoke and more appropriate to the specific building, and that might be better reflected in a dynamic thermal modelling route that's going to pick up those nuances and why you've designed it the way that you have. We can also include the effect of ceiling fans. At the moment, that's actually quite a limited benefit in the software, but we're, again, in the update to TM59, we're hoping to improve that and show a more significant benefit. But we're anticipating that including ceiling fans is going to be quite a useful positive impact on comfort, particularly in homes like flats that are more single aspect, and it's harder to achieve a breeze through openable windows. So generating that breeze from a fan can be a really powerful way of improving comfort. And also, if you're reflecting a design that includes mechanical ventilation or cooling in some way, so MEV or MVHR can both be included in the dynamic models. They may not necessarily have a massive effect on results, but they can improve them. And obviously, the higher the mechanical ventilation rates, the more effective they're likely to be. There are also solutions when you can't open the windows for noise or other restrictions. So just generally more flexibility and more specificality is possible within the models. So the decision about when you might want to use TM59 is made for you in certain circumstances. So it'll be mandatory where the nighttime noise levels are exceeded in Part O. It's not explicit about that, but the reality is that you can't achieve the openable areas that you need for bedroom windows at night under the simplified method when the windows are closed. As simple as that. So there are modelling methods where you can apply alternatives for the nighttime ventilation and still comply. It's also mandatory to use the dynamic modelling route when you have a community heating system. So the heat losses from circulating pipework, heat interface units and so forth needs to be factored into the overheating risk assessment, and that will come through in the dynamic modelling. And also, if there are planning requirements, such as under the London Plan, referable projects are required to do a TM59 assessment anyway. So if you're going to do it for that, you might as well double up and use it for building control, building regulations compliance as well. And then there's the optional reasons why you might choose to use the dynamic modelling route. We've mentioned shading devices. One of the big ones is that you might be in a part of the country where actually the overheating risk is actually very low in parts of Wales and the northeast, for example. And I'm going to show you a slide in a minute that sort of illustrates that a bit more closely. But under the simplified method, we only have high risk and medium risk locations, and the requirements for both are quite stringent. So there is an argument that says lower risk locations should have lower or less onerous requirements for overheating mitigation. And then, yeah, the other reason you might want to use the TM59 route is if you've tried the simplified method and it's not complying, it's failing, despite what you feel to be a good design practice and possibly homes you built elsewhere and never had any problems with. It is quite feasible that if you run it through the dynamic thermal modelling route, you will achieve compliance. It is often easier to pass than the simplified method because of all the reasons we've just talked about. So the regional differences are interesting and I think are very closely related to the Susie weather files, but they're also, broadly appropriate because we do know that different parts of the UK and England and Wales specifically here do have different climates. And you would expect overheating risk to be much higher in London and the southeast than it might be further north. So we've looked at, this is one example, which is in the Future Homes Hub guide that this webinar is summarising here. This is a small semi-detached house, quite modestly glazed, quite sensibly designed. And we ran it through all four key orientations, so north, south, east and west facing. And we ran it through 12 different Susie weather files, which are all listed there on the right. And we picked the east facing, which is where the front door faces east and the back of the house faces west, just to give you a summary here. And I think what's interesting here is that, as is usual when you do this type of analysis, Heathrow is the worst case weather file to try and gain compliance against. We're seeing it non-compliance against both the daytime and the overnight criteria. Again, this is quite normal and you would expect to have to build more overheating mitigation into homes, particularly London and the southeast. And what's striking, I think, is that if you look at exactly the same home in exactly the same orientation with nothing changed apart from the weather file, but take it to Newcastle, you get not a single hour of overheating risk, so well below the thresholds. Yeah, very low risk. And you can see across the country that it does vary, but only Heathrow and Gatwick for this particular unit are showing any kind of non-compliance. So that's quite an interesting, just to bear in mind. And I'm going to hand you over to Richard, who's going to take you through some more specific examples of what we explored using the dynamic thermal modelling method.
Thanks, Susie. So just really to reinforce the point that Susie's making about the difference between simplified and dynamic method. When we were putting the guide together, we had a sort of call for examples, and designers, developers, and some of the people doing thermal modeling put forward house types. And we selected from those ones that we thought would be good illustrations of some of the issues that would surface when you're tackling Part O and how they might be resolved with TM59. And so in the guide, all of the houses actually would have failed into the simplified method. So there's a point just to make really clearly, which is that TM59, with its greater flexibility and greater accuracy, does actually allow you to do potentially fewer modifications to a home or an existing design to get it through Part O. So this house, into the simplified method, the red areas that have been highlighted are areas where additional opening vent or additional opening area would have been needed to get to the house to pass, whereas with TM59, it just passed as per the original design. So next slide, Susie, please. And one of the things that a lot of people were concerned about when Part O was implemented is, well, what happens if I've got a house that's already been designed? I've got planning approval for it. There's good reasons not to change it. And I don't want to go back through the planning process. And that applied to sort of small one-off, specially designed, custom designed houses. And it also applied very much to developers who had a range of homes that they've been working on for several years, thought that they worked well, they understood how to build them, they were, designed for a specific market. And the problem that everybody was beginning to kind of get anxious about was firstly that they wouldn't pass Part O at all, but that some of the quite onerous implications of how the bedroom windows particularly are viewed by Part O. So if you have a ground floor bedroom window, if you have a window that's close to a porch or some kind of external canopy structure, then Part O sees them as windows that are vulnerable, so vulnerable to intrusion or from a burglar. But it pretty much means that you can't use that window as part of the ventilation strategy. So next slide. So here's a house, a one-off design that was put forward and that we looked at. And it's actually a sort of single-story building on the footprint of an old barn. So the fact that it's using the existing structure, the fact that the living room is orientated towards a view, that the client had a planning consent and very much wanted to build it, meant that the design would really have to be taken forward through Part O without any modifications to its orientational glazing pattern. And the only way to get over the issue with the ground floor bedroom windows is to introduce some kind of security or shading device that allows you to have ventilation, but also makes the bedroom window secure. And next slide, Susie. And if you're going down the TM59 route, you kind of need to have the expertise of somebody who's doing the modeling to understand the implications on the restrictions that might be imposed by the shading device. So some shading devices allow quite a good through movement of air through the device. Others, like custom designed weathered louvers, might reduce the airflow by 40 or even 50%. So somebody with the expertise to understand that and to understand how to size that is needed to get over this problem of having both security and ventilation. But there's also, I think, going to be a trend which is kind of interesting in our housing market, much more common abroad, but of having inward opening windows so that you can have ventilation and have a secure device that's in a permanent position. Next slide, please. So the other part of that problem of what to do with bedroom windows is caused where you have a porch or a canopy or some kind of structure over the doors or the ground floor that would allow somebody to get up into the bedroom window. And this is a house that was designed by a housing association who had very particular requirements for wanting to have all of their entrance porches designed so that it was a really useful weathering canopy. And they also wanted to have bins and bike stores integrated with the design, not as sort of separate buildings. So in this design, there's a sort of ground floor loggia that wraps around the house and actually provides some shading to the southwest elevation where the living room windows are. But the bedroom windows, which are highlighted in green, are ones that would be deemed by Part O to be, without some security device, not usable in terms of the ventilation strategy. And when Susie and colleagues modeled this house, next slide, please, we found that it was failing in lots of different orientations. And in a way, that's sort of what you'd expect. So although it seems like it's one house design and it's one part of a semi, it's behaving quite differently in different locations on the street. So you can see on the top left-hand side, the living room has got southwest facing windows, but some north facing windows. And on the other side of the street, it's got southwest and south facing living room windows. And TM59 is a really good tool for being able to optimize the design for all 4 iterations of that house, depending on where it is on the street and what side, what pair of the semi-detached it is. Next slide, please. But very interestingly, we found that the combination of the inaccessibility, or rather the lack of ventilation to the bedroom window, bedroom 1, Susie, if you just click once, you'll get a highlight, I think. Bedroom 1, you can see, failed really dramatically because you can't use it as part of the ventilation and the criterion to the nighttime overheating. But we're also struggling with the kitchen and living dining room, mainly because the front door was glazed and because of the amount of glazing on the living dining elevations. And in the guide, you'll see that there's a number of iterations where different solutions were tested and different options were employed to try and illustrate how the house was performing differently in the model as you tried those different options. So the second set of tables you see, we actually cured the bedroom problem by taking away that ground floor shading device. So we took away the porch, we took away the shading to the kitchen, living, dining room, but actually that had the effect of solving the problem on the bedrooms, but worsening the problem in the living dining area. And the final iteration, there are actually 5 in the guide, but when you get to the final one, it was a combination of measures. So one of the things was to reduce the amount of glazing on the ground floor, so taking away some of the kitchen glazing and also the glazed front entrance door, taking away the porch shading, but then looking at using glazing with a good G value. So in this case, triple glazing has a G value of around about 0.5, and the client was already heading towards triple glazing as part of the sort of solution for the thermal design. So actually that was a good combination of available things. So some things taken away, some window areas reduced, and the glazing specification changed. And then we got a pass in all of the bedrooms and the kitchen and dining area. So next slide. One of the things that we seem to be hearing, and this is sort of feedback from both developers and designers, but also window manufacturers, is that it's very difficult to get homes to work in high-risk locations using the simplified method. So in a high-risk location, the area of glazing is reduced largely, not in every orientation, but largely reduced and prescribed by the simplified method. And then you also have to apply the measures at the bottom of this slide, A, B, and C. So external shutters are, when you start to look at the guidance, are actually quite difficult to implement on a ground floor because they have to cut off the sun angle from 50 degrees. So that's quite a large projection. It's not something you see in housing design very much. You see it a bit in office design, but the projection is very large. Glazing with a G value of 0.4 and light transmitters of 0.7 is actually very difficult to source. So we're hearing that that pretty much doesn't exist in the market. And the overhang, the point of the 50-degree thing, is quite a difficult thing to implement. So we're beginning to hear that actually in the high-risk locations, the flexibility of TM59 actually gives you more economical solutions as well as more flexible solutions. Next slide, please. So these are the kind of things that you can start to look at if you're using TM59. So firstly, you can start to take account of glazing that's designed for specific orientations. So it's not just dealing with south facing, but maybe southwest facing. You can start to think about a combination of measures. So overhangs, external blinds, moving glazing, but importantly, you can also take account of the shading effect of adjacent buildings. So not adjacent trees and landscaping, but adjacent buildings. You can use mechanical ventilation. So in the example of the very small bungalow house that had bedroom windows on the street facade that were a security risk, then one of the solutions that would have worked there as well is to adopt mechanical ventilation. You're just using enough airflow through a mechanical system, providing it runs quietly enough, because the unintended consequence of using mechanical ventilation in the model is that if it's too noisy, people will turn it off and you'll have defeated the whole problem of having extra ventilation to deal with overheating. And then perhaps as a last resort, but still technically feasible, is that you can apply active cooling. And we're seeing in some of the London schemes where they're built by very close to sort of heavy transport infrastructure, airports, large roads and things, and most of the passive measures are no longer available, that actually cooling is a solution that's being adopted. And final slide, I think, is just a pointer to where you can read some of the background guidance. And because Part O is quite unwieldy and quite new to everybody, the Future Homes Hub broke down the guidance into sort of technical guidance and then a more general and much more approachable where to start guide. And then at the bottom is the dynamic thermal modeling guide that we've been talking about today, which is very much based on examples where models have been run and you can follow the changes, the different iterations of the model. So I think our final piece of advice really is very much to use the TM59 route as something that helps you to optimize design. If you just use it to demonstrate compliance, you may not be getting the benefit of the expertise that the modeler can bring you, or the refinement that the model itself can give you on kind of optimizing a solution. So that's the end of the presentation. I think, Chris, you've been collecting questions through Q&A, we hope.
Yes, sir. Yes. We've got a few coming through. So yes, I've got some things I can ask you now. So thank you very much, Richard, and thank you, Susie. So I'm going to start off with a couple of questions to do with the weather files right at the very beginning. So Ken noticed very quickly that there wasn't anything for Scotland, and although the Future Homes Hub is really is primarily there to worry about English regulations, Susie, are there weather files for Scotland, and what is the background for using TM59, and what is in the Scottish standards that might drive that?
Yes, there are weather files available for Scotland. I think there's only one. I think it's just Glasgow, but there is a SIBSE weather location in Scotland. In terms of Part O, specifically doesn't apply to Scotland, but they have an equivalent, which I believe is similar. I'm not fully conversant with it. I think it's quite similar to Part O, and I think it also includes a route using dynamic thermal modelling. So that is available. I think it recognises that overheating risk in Scotland is not as high a priority as it is in London and the southeast, but equally it is possible to overheat with poor design. If you've got a lot of glass and very little ventilation, you can still build homes that overheat quite badly. So so it is still something to be mindful of, but the risk is.
And then there's a very specific question about from anonymous attendee about the Plymouth weather file. So does the Plymouth weather file accurately represent local conditions? Is there a unique microclimate in that area? And I guess there are probably issues around unique microclimates everywhere. So yeah, how representative are weather files, and what about when you do possibly have a risk of a microclimate?
That's a good question. I don't have data on how accurate the weather files are for the locations they represent. I mean, they are based on weather data that was measured in those locations. But I think what you notice with Plymouth is it doesn't show a particularly high overheating risk profile. And I think that's partly because it's quite windy. And obviously, when you've got higher prevailing winds, you open a window and you get more natural ventilation, more air changes an hour coming through a room than you would if it was a more still environment. And that's my hunch about the Plymouth weather file, but I may be wrong, and I'm not a meteorologist. So
okay, right, okay, thank you.
Can I say that I think it is an interesting question, because a pass through Part O with TM59 doesn't mean that there won't be some instances of overheating in that home. So the weather files are giving you typical weather data, based on historical information. But it doesn't account for the sort of situation where you have a heat wave and you have very little air movement and you have nighttime temperatures that don't drop very low and heat's accumulating progressively over a condensed period of time. So the exceedance hours don't necessarily give you an assurance that there won't be some instance of overheating in particular weather conditions. And
that's an important point to make.
It's an important point for people to understand.
And actually, we're not really assessing heat waves as such, because in a heat wave condition, actually the rules and the behaviour changes, because you would close all your curtains, you'd potentially close all your windows during the day to keep the heat out, rather than open them, which is what we do in the model. So, I mean, I can go on for ages, but there is a whole other question about whether we should actually do a separate analysis to look at heat wave conditions, using different protocols for how occupants behave.
Okay. We had an interesting point and question coming in about from an anonymous attendee, talking about having done different TM59 reports for the same house types with different assessors and getting different results. So they're asking, why is there no exam scheme in place to improve the standards? Because we're now in the point where Part O is as important as Part L, and in fact, actually, I don't know, Richard, we might even say that Part O is more important than Part L in many ways. But Susie, what's the situation in terms of quality control and assessment? Because you've probably got your ear quite close to the ground on what people's thoughts are on that up at SIBSI.
It comes up a lot. It's a really good question, and I think I would like to say SIBSI are working on it. I'm not sure. There is a course in development, which I think was due to run and then got cancelled last month. So I think some sort of accreditation scheme would be a good idea. I think that the challenge is that it's the ones we've got today aren't appropriate. So somebody needs to develop something, and as far as I'm aware, nobody has. I think Elmhurst are working on something. They've got a scheme that uses their software, or I think maybe uses IES. So I think they're working on something. But yeah, it is a space that I think somebody will need to fill.
I mean, as you know, if you are thinking I'm going to go off and get some TM59 work done, I mean, other than the advice of using you, Susie, I mean, how can I have any confidence really I'm choosing the right people? I mean, it's bearing in mind this at the moment, or is it I just have to take my chances?
I mean, that is what's difficult, because there isn't a registrar. But yeah, inklingllp.com, very happy to help. Yeah, I think word of mouth is good. I think you should be asking certain questions of your modelling team, and you should be appointing with care to make sure you're getting not just the sort of compliance service where you just get pass-fail answers, but you're actually getting a more supportive service that says, if there are fails, why are there fails? What might you do about it? We'll run a load of mitigation iterations for you to test different options, and we'll actually explore the subject for you and give you some more helpful feedback, rather than just it doesn't work or it does work.
And they also asked whether or not really we should be really doing this for every single house on a site. And so
that's another important point, actually. Yeah, for the simplified method, there is a requirement to do every single unit. Under the dynamic thermal modelling route, you can do a sample set of units. There is some guidance in TM59 about selecting that sample. It needs to be a good representative sample, and that can be discussed with building control. They might push back if you've only done 3 units out of a 100-unit scheme, for example. But if there's a lot of repetition, that can help you. I think you should be looking to do at least one of each unit type in the worst case orientation, but it's sometimes hard to know which is the worst case orientation, so you might need to do a few. Your modeler should be able to give you some support on recommending a sample size and which units should be included. So that's something maybe to ask when you're doing the appointment, and maybe rate them based on how much they engage with that question, how much support they offer you with choosing their sample.
Okay. Ken Gordon has come back and said that the Susie map does cover Scotland, so we got that. I'm glad to be able to confirm that is good. While we're on this consistency question, do you have any information on the comparative results on different modelling softwares at all? I mean, are you hearing anything where people are saying, "Oh, I'm getting different results that go different softwares"?
Yeah, I mean, you'll get very slightly different results just from using different modelers or using different softwares. The trends, I think, are the same. And we've done some analysis where we modeled exactly the same units using TAS, IS, and Design Builder and got very similar answers out. I think there have been other studies that have shown bigger disparities between the modelling tools, but they tend not to publish which tools they are or exactly what they did. And most of them aren't overheating risk studies. So it's hard to be definitive. If anyone's got information, I'm always interested in that kind of thing. We are looking at it, and we're doing some ongoing research with Hilsa Moran, looking at comparing the tools. And our evidence today says that they are very similar, but not identical.
Okay, and Fabrice from AESSC is saying that Elmhurst does have an overheating competency scheme. So, thank you, Fabrice. There's a couple of comments about what we've been just discussing. So anonymous attendee says, as architects, we found benefit where the TM59 modeler is the same as the SAP assessor. And in the north of England, we're advising all our clients to use TM59 rather than the simplified method, as we are finding far more design flexibility, which is goes along with the things that you've also been saying. So that is good. Yeah, I think we've also yes. So somebody's saying, does Elmhurst audit assessments too? I think they probably have to ask Elmhurst that, I would have thought, would they? So right. Right, okay. So I'm just going to go back up to the top of my list. So I've got a few these are quite specific questions, I think, and so I have to say I hope that they make sense to you, because as a layman, they're not making much sense to me. So should window opening restrictions as per BS 8322 be considered, or just the Part O noise limits? Says Jacob Ward. Ask Jacob Ward. That make?
Can we take that one? I'm not familiar with that particular British standard, but if we're talking about restrictors,
yes,
Part O is suggesting that restrictors shouldn't be required because they've raised the sill height requirements. So what they, I think, said was that because 1100 mil sills are required, that should remove the need for any additional restrictors limiting how wide windows can open.
Yeah.
Obviously, there is still the restriction on maximum reach for outward opening windows, and that on a wide window in thick walls can be quite limiting.
Okay.
It's a bit of a grey area, though, as the question is alluding to, because there are things like you can't have windows opening a certain dimension more than 100 mil over parts of the public realm. So if you've got homes that are very close to the sort of footpath pavement, for instance, there are other restrictions that are not mentioned in Part O, which I would have said would have to apply. So whoever's modelling needs to understand all of the limitations on the window opening. Okay.
Jacob's actually come back and said, no restrictors, the window requiring closing due to noise limits under the British standards. So
So there can be, so Part O has specific noise limits at night, which it requires, but there can be additional noise constraints that come through planning or through other reasons on a noisy site that might limit when windows can open during the day as well. So all of those should be factored into the assessment and negotiated. And sometimes those limits are based on the number of hours that windows might need to be open for. So acousticians will say, you can open these windows, but only this wide or only for this many hours a year is acceptable. And then there's a sort of more, dance with the modeler to try and work out, how we can best optimize that within the constraints for the acoustic consultant is specifying. So it's often a conversation, but I think modelers and acoustic consultants need to be better at communicating and more commonly. I think it's getting a lot better, and there are some consultants that offer both now, so that, again, because you need that joined up service so that you can ensure that the overheating risk assessment is following the same guidance.
Okay. Kamil Hamala was asking, and so this is a question about balconies and when they are accessible or not. So said, if the balcony floor is at 2.5 meters, but the balcony rail is at 3.6 meters, would you class it as easily accessible or not?
I had that question last week. It's a really good question. I posed it to HSE and they referred me to building control. So basically you have to ask that question of your builder control officer and see what they say. I think it for me, it would depend on the type of balustrade, and if it's solid, you'd think it's then creating a much higher climb, you know, you can't climb up it. If it's railings, it might help you climb up it. So I guess there's a logic there. But yeah, it's a good point, and I haven't been able to get a definitive answer on that.
Okay, right. Okay, so yeah, ask early, I guess, is it? Yeah.
Well, that's right, because the hub fielded quite a lot of questions when Part O was implemented along similar lines. So I've got, you know, bedroom windows on the ground floor, but the garden is a solid wall construction, you know, past is secure by design. Is that a secure or is that not a secure, you know, bedroom window? And the pushback from was pretty much always, you know, refer to building control. It's a question for building control's judgment. We didn't get any clarity on those fairly vaguely drafted requirements. Yeah.
Which is frustrating in early design.
Yes, that is very frustrating. Yes, yes. We've had a comment also about the availability of the glazing units that that you were talking about, Richard, with the 0.4 and the 70%. So somebody here is saying that they think they are fairly widely available, but really expensive. So, but
that's
I mean,
absolutely right. It's the technology that's used in, you know, in really sophisticated office design and things. The technology is available. I think we're hearing it mainly from window contractors, actually, who are probably pricing projects and saying, you know, it's just not available, but it is, but it's expensive.
It's available, but you don't want to pay that much if you're a developer. Okay.
That might change if demand increases.
Yeah, absolutely. Yes, that's true. Yes, yes, it could well change, couldn't it? Got another anonymous one. What flow rates mechanical ventilation is required to tackle overheating in bedrooms with closed windows? And at which point do we assess the dwelling under mechanically ventilated criteria and not naturally ventilated ones?
Okay, this question comes up quite a lot. The answer to how much you need in bedrooms at night will depend on your location. You need a lot less in cooler parts of the country because, you know, it's cooler at night. So more in London and the southeast. Sometimes it's as low as 10 litres a second for a bedroom. Sometimes it's a bit more. But that is something that your modeler can help address with you and answer for you. The question about, we're actually working on an update to TM59 at the moment that is going to give more guidance on when to use the different predominantly naturally ventilated versus predominantly mechanically ventilated criteria. And the stance we're taking at the moment is that if it's just at night because of noise constraints, then you can still use the predominantly naturally ventilated criteria, but the windows need to be openable during the day. If there's constraints during the day as well, and those windows can't open during the day as well, then you'd need to move to the mechanically ventilated criteria. Okay, but that can be done on a room by room basis.
Right. Okay. And another one for you, Susie. Susie mentioned the ceiling fan as one of the design options, but would it circulate fresh air at night when bedroom windows are closed? If there's no fresh air circulating, how would this be an effective measure to reduce overheating?
Yeah, no, it doesn't introduce more fresh air. I mean, it can help when the windows are open to help draw more air through the windows that are open. But if the windows are closed, I mean, presumably there's still some Part F background ventilation coming in because that's a building regulations requirement. But what it would do is generate a breeze, and that breeze across your skin means that you adiabatic cooling, you evaporate some sweat from your skin and that cools you off. So we know that just, you know, being in a breeze is cooler than not being in a breeze. Dehydration becomes more of an issue, so be mindful of that. But that's, I mean, I think most people are aware that, you know, just fanning yourself in hot weather feels pleasant. So it's that effect that ceiling fans produce rather than an actual change to the air temperature itself.
Okay. Ken's asked, is the new revision of TM59 planning to include the benefits of passive cooling already available from high-end ground source heat pumps? Do we know?
So are we talking about comfort cooling sort of, yeah.
Yeah,
so,
well, yes.
Yeah. It's already, you can include that in your models. We often see, for instance, MVHR units with a very small cooling coil in them, but you can go full mechanical cooling as well. We are TM59 is agnostic about the source of that mechanical cooling, but Part L will take a keener interest in the energy used to create the cooling when it's active.
Okay. And when do you think the TM59 revision is coming out? I thought you said later this year, but did you say that?
Yeah, so we're hoping to get that out in the next few months. We're still doing some final testing at the moment, but it's hoped that it's going to be coming out in the next few months. So yeah, watch this space.
Okay, I've got another real super techie question here as well. Is the reduction of internal relative humidity through mechanical ventilation given any consideration or benefit with any of the standards of the models?
Dehumidification, not really, because it doesn't generally impact on overheating risk as we measure it, which is done on resultant temperature.
Okay.
Models.
Yeah. Okay. Oh, I got, sorry. What's happened is that they come back round at the bottom. So I'm going up and down the list. So if I'm slightly coming back to some stuff. So we had a question about fans earlier. My assessor has specified 70 litre per second fans, but they don't exist. And if they are too loud. Is 70 litres per second common?
That's a lot. That is a lot.
That is a lot.
The challenge is that mechanical vent is very hard to compete with openable windows, because if you open a window wide, you're going to get a lot of air through, and actually the air changes an hour are really high when you've got a wide open window, particularly if you've got some cross vent. And to achieve that mechanically is really difficult, and you end up blowing air, which is noisy and unpleasant often. So yeah, I would have thought 70 is high for one room. Spread across a whole home, maybe less so, but for one room, that's a lot.
Okay. We've got a couple of questions about building control enforcement and whether or not they're really getting involved with Part O yet. I mean, I guess it's probably extremely variable across the country, but what's been your experience of that? And I suppose there's a question of whether or not we need to actually educate building control officers on Part O. But what are you seeing from the cold face, as it were?
Do you want to take that one, Richard?
I think it's a good point, because I'm not sure that even in London, where most of our schemes are, and we have been doing overheating assessments for sort of 3 or 4 years, whether building control actually engages with the results. You know, they'll get a report, and the report will have a summary set of recommendations, and they'll be interested to know whether those have been applied or not, but they're relying on the expertise of whoever drafted the assessment. So it comes back to that question about why do you get different answers when you do the model in different ways, or why do different assessors arrive at different models? And I think you have to be very clear about why you're doing it, if you want to design a building that doesn't overheat, or whether you just want something that complies with building regs, because there won't be any further dialogue really. But you know, I mean, to be honest, Chris, people struggle to get their heads around Part O. You know, in the consultation, lots of people were saying this could be done differently, or it could be clearer, or it could be easier. There was a lot of confusion. So it's not surprising that building control are struggling to get, you know, heads around it as well.
Okay, thank you very much. I've got I'm going to ask another question, but I did just want to check with Ken Gordon's written a couple of well, actually 2 or 3 things about 3.28. Ken, I think they're mainly, I'm not certain if there's if we've answered those questions or not as we've gone on, partly on account that I'm not enough of an overheating expert to tell. Please ask us another question if I failed to grasp what is probably a very basic point you're trying to make, but let me know if we haven't answered that. In between time, somebody's actually asking, we talked about 70 litres per second being a lot. Someone's actually asked a very specific question, like what is a common litre per second of a fan in a Gatwick weather file with a room with security risk? I mean, but I suppose if I broaden that out slightly, what sort of fan, litres per second would you sort of expect to see? I suppose might be a slightly broader term if 70 is a lot.
10 is common.
Oh, right. Okay. So
10 to 20.
That's a lot less.
It's quite a lot less.
Yeah, I think in the one illustration in the guide that we had, we said modeling with up to 20 litres per second as that being about the sort of threshold being confident that the ventilation system's not going to be noisy. So we didn't, in any of the sort of analysis of the houses where we did use increased mechanical ventilation, didn't go above that.
Okay. And I haven't had anything back from Ken, so I think we must have answered his questions. The anonymous, so I've got my, I'm heading towards my last question, and unless there's any other points you'd like to make, Rich and Susie, which was somebody said, why is TM59 so expensive, and how long does it take to do? So I think I think people have got an idea of what, what's involved in a SAP assessment, but the TM59, we've got no idea how much work is in that. But I guess it's also a bit of a supply and demand issue at the moment as well.
Yeah, but it is genuinely time consuming, because when you have to build a 3D model for the sample units that you're assessing, that takes a bit of time. You've got to make sure they're accurate. You've got to input a lot of information about the building fabric, about the windows, how they open. You've got to measure a load of stuff from the drawings. You've got to check a load of information about sill heights and all the rest. But there's quite a lot that needs doing. There are significant economies of scale. So doing, a 100-unit scheme is going to be cheaper per unit, but in quite a long way, than doing a single private house. But yeah, there are costs, and it takes someone with quite a lot of experience and expertise to run a model 2 or 3 days at least, to get the results. So you will get some people who are cheaper, but they may not offer the same level of service.
Yeah.
And yeah, it's a tricky one, because what we're trying to do is make sure that lower risk homes could go through the simplified method. That's one of my frustrations with Part O, because it's unfair on homes that are lower risk to have to do the more detailed modelling. I think it's reasonable where there is a higher risk, and that's particularly London and the South East, where land values are higher, so probably should be easier to support the additional costs of a TM59 assessment. But I don't think homes in the North East should routinely having to go through TM59. That does feel
okay. We've got a couple of other things that have come up. So Ken's apologised for causing me confusion, which doesn't take much, Ken. So section 3.28 is the reference to the Scottish standards with regards to dynamic thermal modelling analysis. So thank you, Ken. Glenn is saying he's seeing flow rates between 10 and 40 litres per second. Okay. And
it is possible to achieve higher flow rates, and you might just need more support from a manufacturer to give you the right kind of grills and fans and so forth to enable that quietly.
Yeah, and he's also come back saying actually also you have to pay for your software for TM59, and the weather files are expensive, whereas SAP is free. So yes, thank you very much for pointing out that one, Glenn. I think we are. I think we've just about done. Nothing else has appeared on there, and so I just want to say thank you so much to Richard and Susie for being in the firing line for that, and helping us through Part O. It's it's been quite a journey with us with Part O. We've all been learning an awful lot very quickly. We are aware, of course, that we were just discussing before we came on that there is reference to Part O in the Future Home Standard. Susie, could you just remind me what the Future Home Standard consultation is asking about Part O, if people want to contribute to that?
Yes, I think there's about 7 or 10 questions about Part O. Specifically, they ask about whether it should be expanded to include change of use for homes created from offices and so forth, and I'd argue that would be a good idea. And also just a little plea, as we've mentioned, we're updating SIBSE TM59 at the moment. If that doesn't get adopted into the Future Home Standard, the new update, then it's a bit of a lame duck, and it would be nice that if all the work that we're putting into improving TM59 manifests itself in being adopted into the Future Home Standard when that comes out, so that the latest version is active. We've not had any response from the powers that be.
And is there a general question about what people might want to see changed in Part O at all?
Yeah, so there's some quite open questions about where it could be improved, particularly for small house builders. So if you do have feedback, I would recommend, the deadline is 6th of March. If you can put in a plea for adopting Part O, that would be brilliant. Sorry, the new TM59, that would be brilliant. And if you have feedback on what isn't working about Part O, that's it's an opportunity to feed that back to HSE who are supervising it now. And
Yeah, and we will see some
Yeah.
of the idiosyncrasies. Some of the idiosyncrasies of Part O have been highlighted in the documents, which are available on the Hub website anyway, aren't they? So if people want to quickly remind themselves of some of those things that other people have spotted, but I'm sure other things have come to light as people have been using the tools. Anyway.
I've written quite a long response.
Thank you again, Susie, Richard. Always a pleasure having you, and really grateful for your input. And thank you very much to everybody who's joined us on this webinar. And I hope we'll see you in some of our future ones, including the one that's coming up in a fortnight time about heat pumps, a builder's perspective. Thank you very much and goodbye.
Thank you.